Welcome back. This is the second half of a two-part video all about passive tone controls and passive bass wiring in general. If you missed part one, you're more than welcome to stick around and just kind of stumble along blindly with no real context. It's pretty much how I make these videos in the first place, if I'm honest. But if you do want to watch part one, here's a link. Until I started making these videos, I always wondered why YouTubers never knew which way to point when they're referring to a link card. Turns out selfie cams reverse the image so it's mirrored when you're recording and then reverse it back for playback. It's very confusing. It's nothing to do with basses, but yeah, fun fact. Okay, so the Fender's all back together again, although it has a black pickguard on it now for various reasons. But I think it's time that we did some recording with it, with all of these different caps and so on, just to see if our ear can make a little bit more sense of what we've seen on the screen and in simulations. So for that reason, I put together a little test rig, and I can blue tack those controls to the front of the bass. Okay, so here's my test rig. I've got a resistor and a cap, again in parallel from hot to earth, and this is for simulating the resistive load of the volume pot as well as the capacitive load of the cable. And here they are on the actual rig. They're my two resistors in series, summing to 250k, and then I've got my 470 picofarad cap wired between the earth and hot. The reason I'm using cable capacitance is because I'm going to record with this guy, which actually has, I built this years ago, it actually has a FET buffer built into the plug, and this I know has a 1 meg input impedance. The reason I'm using that is because I really want the recordings to sound as close as possible to what we've seen on the screen and with the scope. Here's my tone pot, wired as usual, but this time instead of a single cap, I've got a rotary switch. This has actually got 6 positions, this rotary switch, but I'm only using 5. The first position is not connected, so this is an open circuit, and it allows me to disconnect the tone pot altogether from the circuit. Then I've got 3 caps, a 22, a 47, and a 100 nanofarad cap. I know I didn't actually do any sweeps with 22, but they do rock up in certain basses. The 5th position is a short directly to earth, so we can have a listen to that, that roll-off that we get without a cap at all in the circuit. I should say that this bass doesn't have a traditional P-bass circuit in it. In fact, it's got a switched cap type tone control, and if you're interested in how I designed and made this, I do have another video on my channel all about that. It's very similar to this one. The bass also has a no-load volume control, which is different from a no-load tone pot, which you can just buy from guitar parts suppliers. You'll have to make your own if you're interested in a no-load volume control, and yes, I have a video on that as well. The reason I'm mentioning this is partly because I'd like to blatantly cross-promote the other videos on my channel, but mostly because with this bass, when both controls are dimed, there's no resistance or capacitance across the pickup, so there's no loading at all. And that means for this, I can simply plug straight into the jack and essentially access the pickup unloaded, just as it was on the bench when we were doing our sweeps. So let's get on with it. Okay, I've got my test rig all blue tacked to my bass. But for the moment, in fact, I think for the first test, I won't actually use it because, as I mentioned, with the controls in this particular bass dimed, it means the pickup's actually directly wired to the jack, and aside from just a short length of pickup wiring, essentially it's seeing my 1 meg input impedance from this FET buffer directly at the jack, so there's no cable capacitance and there's no loading from pots. So let's have a listen to how that sounds, I think. I think if you're listening on headphones, like I am, you can really hear that treble peaking at about 3.5 or 4K, I think it was, on our screen, and it certainly sounds to be right up there. The bass really doesn't sound much like a P bass. FYI, the bass does have brand new strings on it. They are Elixir, just standard gauge Elixir strings. The next test I think I'll do is I'll just roll my no load volume pot back ever so slightly, and we'll just hear the difference between having basically a 1 meg loading on the pickup and what is essentially a 200K loading on the pickup once this is in parallel with the 1 meg. So here's open. And that is with the 250K pot back into play. So 1 meg, 250K. Just like I say, it doesn't shift that 4K peak in frequency, but it damps it, and I think you can, well, I can certainly hear that there's a slightly warmer tone in the treble. Okay, let's move on to my test rig. So the test rig's now patched in, and I think we're going to start with position 1 on the switch, which means the tone pot is not connected, so it's out of the circuit. So now we're hearing just the 250K load resistor and cable cap in the test rig itself. Well, I think it's sounding a lot more like a P bass normally would when you record direct with a P bass. Anyway, I think the next test we'll do is to compare our 3 caps and our short circuit. That's really what I made the test rig for, I guess. So we'll start with position 2, which is our 22 nanofarad cap. Then I'll switch to the 47, the 100, and then the short circuit. For this first test, I'll have the tone pot all the way up. Okay, that's a 22 nanofarad cap. Let's try the 47. Not sure I can hear any difference. We'll go back to the 22, 47, 100, short circuit. Okay, so obviously the cap really is not in play just yet. So why don't we wind the tone pot back by 1/4 to about 7.5 and see if we can hear a difference in those 3 caps and the short circuit. So position 2, 22 nanofarads. The tone is ever so slightly warmer, but that's, I think, just because we've rolled the tone pot back, not because of the cap. Let's try leaving the tone pot where it is, and I'll switch between the caps. Here's the 22, 47, 100, short circuit. Obviously the cap's really still not in play, so I'm going to wind the tone down to half. The tone control's now on 5. Let's switch between our 3 caps. Here's a 22. I'm slapping and strumming because I really want to get a nice bright tone, because let's face it, the tone control is all about the treble, but certainly in this region it's all about the treble. I've noticed this bass needs a fret dress, so it is a little bit rattly, but with the new strings, hopefully you can really hear the treble. As I mentioned, try listening with good headphones, or even plug your iPhone or something into your amp. Short circuit. So again, even with the tone control rolled down to 5, as expected, and as we saw on the screen, well, I can't really hear any difference between any of those 3 caps and even a short circuit. So we'll take that another step, and we'll roll the tone control down, I guess, to 2, almost all the way down, so the tone pot's on 20%, and we'll have a listen to our 3 caps. 22, 47, slight difference there maybe, 100, and here's our short circuit. Short circuit, 100, short circuit, 100. Yeah, just so around about 2, that's when these caps really start to come into play, and I think you can just hear a volume change with that short circuit when you compare it to the caps. But to be honest, even with the tone control at 2, the 3 caps, I'm struggling to hear a real difference. No, it is audible. It is slightly audible through the headphones. Okay, let's move it down to 1. So the tone pot's just on 10%, I guess you could say. Have a listen to our 3 caps. 22, 47, 100. Okay, it's pretty obvious. Now the cap value is starting to come into play. And finally our short circuit. And the bass is clearly starting to lose volume as that tone pot starts basically acting like a volume control. So finally, I'll turn the tone pot all the way down, and as I mentioned, that effectively removes it from the circuit. So now we just have the 3 caps in our short circuit, 22 nanofarad. Still has that slightly honky mid-range there. Now 47. Played a lot of P basses, that's the sound you know and love. Here's our 100. $47, 22. So those 3 different values are really quite obvious. If I switch to position 5, you probably guessed what's going to happen. We've got essentially a mute switch because we've shorted the pickup to earth. There is something else I may test. There's a lot of talk about what the effect that different types of capacitor of the same capacitance have when used in passive tone control. So I guess I couldn't do this epic video about passive tone controls without comparing some caps. So here are the 3 that I'm going to put in my rotary switch. I'll leave the green cap that's in there. Those are very common in basses and have been since the 80s, just like this little green guy. They're typically rated at 50 to 100 volts, which is way more than they need to be, but they're made to typically something like 5% tolerance, plus or minus 5% tolerance. I'm also going to put one of these things the famous orange drop cap. These are typically used in high voltage applications like valve amps and so on, and perhaps that's where they get their sort of old school aura, I guess you'd say, because they're rated at 200, 250, sometimes 300 or 400 volts. So that's the second cap I'm going to switch between. And finally, the third cap I'm going to use is this little guy. I'll try and get it near the camera. It's a surface mount cap, and I've just soldered a couple of leads to it so we can put it on our switch. If you use any modern electronics, pedals to DIs, preamps, bass amps, especially modern ones that are so small, these electronics will all have surface mount parts. I would think if you plugged your active bass into a couple of pedals, a DI and an M-box, and did some recording, your signal would be coupled or filtered by any number of these types of caps. So here's a 47 nanofarad cap, so I'm going to put that on our switch as well. Alright, I've got my three caps of equal capacitance but varying manufacture, all wired to my rotary switch. I did measure these caps, and the three of them are all not identical, but they're very, very close to 47. They're all within, I think, about 2% from 47 nanofarads. So first, I've got the tone pot rolled all the way down, so we're just listening to the tone cap, and we'll start with the 47 nanofarad green cap. Alright, let's listen to the orange drop. Okay, now let's listen to the surface mount cap. Well, I can't really hear any difference. Let's try some direct comparisons. Well, I've messed around with those three caps a little while longer, and I've also listened back to the recordings, and I'll be honest, I really can't hear a difference between those three types of cap. But I don't really have a problem with people putting orange drop caps and stuff in their bass. I mean, when you modify an instrument, it just brings you closer to that instrument. It makes you feel like that instrument's more of a friend. Music's an emotional thing, and the way you feel about your instrument really does affect, I think, the way you perceive the sound, the way you interact with that instrument, and the way you feel the music. What I'm not so keen on is when people advertise orange drop caps and other types of caps as having this magical kind of vintage tone. To be honest, the instruments I've worked on from the 60s have normally had caps like this, large disc ceramic caps. But there's tons and tons of different types of caps you can try out in your bass, and they're really not that expensive. It's not like people are getting ripped off by hundreds of dollars here. Well, I think that'll do us for this video. I'm sure there's plenty more to say about passive guitar wiring and so on, but I think the most important thing to take away is to understand that all of the passive components plus the guitar lead itself interact in a passive circuit, and they interact with the pickups as well and affect the treble response, especially for those pickups. And in fact, if you have a guitar or bass with two pickups or even three pickups, then those pickups interact with one another as well when they're blended or when they're summed with a pickup switch. And finally, everyone will tell you that a tone controller works because the cap bleeds treble to earth. Well, I'd have to say respectfully that for a long time I've felt that that was really an overly simplistic explanation of how a passive tone control does its thing. So I hope this video has kind of shed a bit more light on that for you, and I hope you've enjoyed the video, but more so I hope it's encouraged you to get your soldering iron out and have a go at some of these mods. Maybe make a rotary switch with some different caps on it and mess around with your bass that way. Please go ahead and like, share, subscribe and comment. I've got lots of other videos in mind on modding pedals, making preamps, modding pickups and guitars and basses. So I'd love it if you subscribed, because there's lots of things in the pipeline. I'm trying to get better with each of these videos at how I shoot them and edit them, and all this business of talking to the camera I'm not really very good at. Hopefully the information in these videos sort of shines through and above the slightly amateurish production values, but I do appreciate your support, and I hope you have enjoyed this and all my other videos, and I'll see you next time.